Hey, welcome to Tammy the Tutor. Today we're in CC2, lesson 1.2.5. The first problem is 103. It says Lila rewrote 10/25ths as 40/100ths and represented it with the picture at right. Tony thinks this fraction is also equal to 2/5. Is Tony correct? Use the picture or calculations to explain your reasoning. Write your answer in complete sentences. Okay, let's see if Tony is correct. He thinks this fraction, which is 10/25ths and 40/100ths, is equivalent to 2/5. So, all you need to do is see if you can reduce these fractions. First of all, let's just make sure that you feel good about 10/25ths and 40/100ths being equivalent or equal. So if we were using a giant 1 to make 10/25ths larger, all we have to do is make sure we multiply the top and the bottom by the very same number to see if we can get 40/100ths. Well, ask yourself, how do I get 10 times what is 40? And that would be 4. And if this is a giant 1, if there's a 4 on top, there's a 4 on the bottom. That's what makes it a 1. 4 divided by 4 is 1. Well, times 4 is indeed 100. So if you weren't completely sure, at least you can see now that those two are equivalent. Well, let's see. How about 2/5? How does that play into this? You can play around with this fraction to get to 2/5. You can play around with 10/25ths. I think that one actually might be easier for you. Both work, but let's do that one. Okay, let's use the giant 1. Ask yourself, how do you get from 10 to 2? Well, this time we're obviously not multiplying because we're going from a bigger number to a smaller number, but that's okay. We're just doing the opposite, which is dividing. You just can never add or subtract in these situations. It's always multiply or divide. So 10 divided by 5 does give us 2. So if this is 5, this is 5. And 25 divided by 5 is 5. So we have made sure that 2/5 is equal to both 10/25ths and 40/100ths. Okay, let's see, B, how could Tony write an equivalent fraction using tenths? That is, what fraction in the form out of tenths can represent Leah's picture? Okay, let's go back to this again. Let's use, 2/5, but now we want an equivalent fraction that has a denominator out of 10. Well, 5 times 2 is 10, and 2 times 2 is 4. So 4/10 would be the answer for B. And that also is really easy to link that relationship between 40/100ths and 4/10 because you can see if you just divided this top and bottom by 10, then you got 4/10. Okay? I guess we could play around with the picture. Some of you may have chosen to just do it with the fractions like I've shown you because it says use picture or calculations. But let's just look at the picture and talk about how that shows us as well. So first of all, 10/25ths. Well, this, if you count them, has 25 equal rectangles. So that would be the denominator. And out of 25, 2, 4, 6, 8, 10 are shaded in. So this does show you 10/25ths. Can this show you 40/100ths though? Have any of you looked at this and can you decide how this picture can possibly show me 40/100ths? Or actually 2/5 even, because we even said that's equivalent. Well, let's look at 2/5 really quickly. If you were looking at this as just like this, okay, and out of 5 equal columns, there are 2 columns shaded in. Do you see that? So that's also showing us 2/5. Okay, now let me show you how we can make this out of 40/100ths. So right now there are 5 columns. I'm going to draw a line in between here, and I have just doubled the amount of columns there are. Sorry, that's not perfectly straight, but There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm also going to do the same thing this way. So that means I'm going to turn these 5 also into 10. So now you can agree that there are 100 total. And if you were to count every individual one of these boxes now, you will see that there are actually 40. Okay. Zaria wants you to solve this puzzle. I am thinking of a number. If you divide my number by 2 and subtract 4, you will get 2. What's my number? Show how you know your answer is correct. Okay, we just need to turn this sentence into a math sentence or an equation so we can solve it. And these really are not difficult. If you just write down exactly what they say, be very literal here. It says, I'm thinking of a number. We've done one of these before. Anytime you have a problem like this and they say, I'm thinking of a number, that means they don't know what it is. You're going to use a variable. You don't know what that number is yet. Great, fine. Just use a variable for now. If you divide my number by 2, okay, whatever that number was, we're dividing it by 2, and then you subtract 4, you will get 2. Perfect math equation. We can totally solve this. You can either undo it by kind of thinking backwards like this. Like sometimes I will cover this up and I will pretend it's not here. And I'll ask myself, something minus 4 equals 2. Well, would you agree with me that 6 minus 4 equals 2? So really the only thing that we need to figure out is how do we make this little operation equal 6? What divided by 2 equals 6? That would be 12, right? If x were 12, think about it. We'd say if 12 were divided by 2, subtract 4, we should get 2. Well, 12 divided by 2 is 6, and 6 minus 4 is 2. Okay? But sometimes it's not really easy to think about it backwards like that. This one is pretty simple, and it is. But let me just go over how to solve a math equation because sometimes they're bigger than this and it's maybe too much to do mental math to think backwards. So if you had a problem like this, but maybe it didn't have a fraction, if it just looked like this, you probably wouldn't be scared of it at all, and you would know what the first step is, and you would think, oh, well, the first thing I need to do is get rid of this negative 4, and that would be by adding 4 to both sides, right? Well, this is no different. Just because this is in a fraction form, there's no difference. You still need to do that step. So we're going to add 4 to get rid of this negative 4 on this side, but what you do to one side, you must do to the other. So we're going to add 4 over here as well. So now all we have is x divided by 2, that turned into a 0, equals 2 plus 4 is 6. Okay, so again, we're at what divided by 2 equals 6? Well, in algebra, when we want to solve an operation, we have to do the opposite operation of what they're doing. Remember up here, they were subtracting, so we did the opposite. We added. Well, right here, they're dividing. So we're going to do the opposite, which is multiplying. I'm going to multiply this whole thing times 2. But what I do to one side, I must do to the other. And if you are used to cross-reducing, you can see it. 2 divided by 2 equals 1. Well, 1 times that x just leaves me 1x. 6 times 2 is 12. You could up here have put this over a 1 so it looks like a fraction times a fraction. And look what happens. You know when you're multiplying fractions, you multiply straight across with the numerators, and then you multiply straight across with the denominators. So 2 times x is 2x. 1 times 2 is 2, and then still 2 divided by 2 is just 1. So it leaves us with 1x. So x equals 12. Rewrite each fraction below as an equivalent fraction and as a percent. Okay. As an equivalent fraction. Okay, we've got 5/20. I need an equivalent fraction. So because we are about to turn these into percents, I think the smart thing to do, or the easiest thing to do actually, is to make an equivalent fraction out of 100, because we have to turn it into a percent. And we know by now that if something is out of 100, the numerator automatically tells you what the percent is. So 20 times what would give us 100? Here's our giant 1. Wouldn't that be 5? So 5 times 5 is 25. And so that means 25%. So here's our equivalent fraction, and here's our percent. Some of you may have thought, well, I want to take 5/20 and I want to reduce it to make it smaller. I think that's something that we have nailed into your head so much, that if you have a fraction that can be reduced, then do it. And that's great. And honestly, if you had done that, it probably would have been just as easy, because we could have divided both sides by 5 and gotten 1/4. And so many of you are recognizing now that 1/4 is the same thing as 25%. Okay, now we have 9/25. Okay, so think about 25 as being a quarter, as in money. And how many quarters does it take to make $1? 100. It would be 4. That's why I chose 4. So if I'm multiplying the bottom by 4, I'm multiplying the top by 4. And that's 36 hundredths, which is the same thing as 36%. Okay, this one is 9/6. Okay, so on this one, there's nothing that I can multiply 6 by to go to 100. So my instincts tell me to try to reduce, and then I'll see what makes sense at that point. So a 9 and a 6 can both be divided by a 3. So I can still use my giant 1. Just remember, we're dividing, not multiplying. 9 divided by 3 is 3. 6 divided by 3 is 2. Okay, so we have 3 halves. Ooh, now that we have a 2 as a denominator, we can get to the 100 if we want to. 2 times 50 gives me that 100. 3 times 50 is 150. So that would be 150%. Okay? Okay, rewrite each expression as a single fraction. Okay, 3/8 plus 1/8. Okay, that's super easy. If they have the same denominator, you keep it and you simply add the numerators. 3 plus 1 is 4. This can be reduced, however, so we need to do that. Well, if 4 is half of 8, that really reduces down to 1/2. I'm going to stack this vertically since I need to get a common denominator. I like to use my giant 1, and it just is a little cleaner this way. So out of a 5 and a 4, I need to decide what my common denominator is. Many times it really is just taking both of those denominators and multiplying it times each other, and 4 times 5 is 20. Okay, so here's my giant 1 in between. 4 times what is 20? 5. Come up here really quickly. 5 times what is 20? That would be 4. Now that I'm all set up, all we need to do is just multiply straight across. 4 times 4 is 16. 3 times 5 is 15. And now we can just keep our common denominator and add 16 and 15, which is 31. Okay, that is an improper fraction, so we just need to change it into a mixed number. So you can either realize it's 31 divided by 20. So 31 is being divided by 20. That goes in once. 1 times 20 is 20. Subtract with 11 left over. So it goes in one whole time. And out of 20, there were 11 left over. Okay, 6/7 minus 2/5. Okay, a 7 and a 5, I'm going to use a 35. Set up our giant 1. 5 times 7 gives me 35. And 7 times 5 gives me 35. 6 times 5 is 30. 2 times 7 is 14. I have my common denominator. 30 minus 14 is 16. I don't think that can be reduced, so that's all we need to do for that one. Okay, 107. What is the length of the marked portion of each line segment? Copy the segment onto your paper before finding the missing link. Assume that the entire line segment is subdivided into equal sections. Okay, we've done one of these before, and remember, all you need to do is decide how many sections is 75 being divided into. And there's 1, 2, 3. 75 is being divided by 3 equal sections, and that would be 25, because if you have 3/4, you've got 75 cents. That means from here to here is 25. From here to here is another 25, so this marker should be 50. And then if you added another 25 to 50, then there it is, and it gives you 75. However, the question is only asking, what is the value of this little length right here? And from 0 to that first tick mark represents 25. So that is the answer for A. So B, 75 now is being divided into 1, 2, 3, 4, 5 equal parts. 75 divided by 5 is 15. This time, they want to know what it represents with 1, 2, 3 of those sections. So 3 times 15, well, let's just do the first tick is 15. Add another 15, you're at 30. Add another 15, you're at 45. Right there. Those 3 sections represent 45. Okay, this time 50 is being divided into 1, 2, 3, 4, 5 equal parts. So that's pretty simple. That would be 10. But they want, let's see, there's 10, 20, 30, 40, and then 50. They want to know how much is 1, 2, 3 of those sections. Well, 3 times 10 is 30. I think that's it, you guys. That was not too bad today. Thank you so much, and I'll see you next time for the next section.